Hi everyone. So again, this week we are working on factoring. And last week we said factoring is taking a trinomial and it's breaking it into simpler pieces with a multiplication in between those pieces. So really we're taking a big long equation, we're trying to break it down into simpler terms so we can see what would end up multiplying to get that trinomial. So this week we're factoring using two different methods, and this week is more of taking the FOIL method and working backwards. So the FOIL method, I would have two binomials like this. I would multiply, right? I would distribute the x both times and distribute the p both times, and we would simplify it to get this big long polynomial. Now we're working backwards. We're taking a trinomial and we're factoring it into two binomials. Last week we took out the GCF, which was just a monomial times a polynomial. Now we're taking a trinomial, we're breaking it into two binomials. So our goal is to split it into two separate binomials. So I would have x plus or minus some number p and x plus or minus some number q as my final answer. And once I had these numbers for p and q, I could move forward and find the roots of these by setting both of these binomials equal to 0. So the main thing for both of these methods, the main thing that we're looking at is the b and the c term. And we're looking at the p and the q term as well, right? So the p plus the q term, right? These two numbers and the ends of our binomials here, they have to add up to give me my b term. Okay, so whatever that number is for b in my original trinomial, these two numbers have to add up to it. They also have to multiply together to give me my last term. They have to give me my c term. That is true for both my parentheses method and for my x method that we learn in this section. So moving forward, we want to start with the parentheses method. And before I say that, I want to just note, you guys can use either one of these methods on any of the assignments, anything that you feel comfortable with. I'm never going to put a question that says factor this specifically only using the x method or only using the parentheses. This is just to give you guys options of what you find is easier, so I'm not just restricting you to one method. So you can use either one of these methods. It's whatever you feel most comfortable with using. So if you feel comfortable using the parentheses method, use the parentheses method on everything and don't even worry about the x method, and vice versa if the x method works best for you. So some rules to keep in mind. These rules will help us a lot on the parentheses method. So if I have a trinomial like the one above, and my b term and my c term are both positive, then I'm going to have addition in both of my binomials. I'll have something that says like x plus p, x plus q. So both of my binomials are using an addition sign. If I have something like this, but I have x squared minus bx minus c, right? So b and c are both negative, then one of these binomials is going to use addition, and the other one is going to end up using subtraction. So you have opposite signs in your binomials. If I have b being positive and c is negative in my original trinomial, again, I'm going to have one that uses addition and one that uses subtraction in my final answer. And then my last one, if b is negative but my c is positive, then both of these binomials are going to end up using subtraction in them. Okay, so like I said, these will help us more so in the parentheses method, but also in the x method a little bit when we double check our answers here. So let's move on. We'll do a couple examples together here. Oops. Okay, so we have a trinomial here. Right? I have y squared plus 2y minus 15 equals 0. So I first want to use the parentheses method. So the parentheses in step 1, I set this up as my two binomials where I have my y's at the beginning. Okay, then I want to take a look at the signs here, right? I have a positive b and a negative c, which means I'm going to have addition in one parentheses or one binomial and subtraction in the other binomial. Okay, now I need to figure out what these values are going to be, right? I need to put in a number for p and q here. So I need to figure out what two numbers multiply to give me negative 15, but they add to give me 2. So to do this, and we wrote it in the notes, to do this, we want to start listing out the factors of negative 15. I'm trying to find two numbers that multiply together to get negative 15. So I could multiply 1 and negative 15. I could also multiply negative 1 and positive 15. I could multiply 3 and negative 5, or I could multiply negative 3 and positive 5. Okay, and that's it for negative 15. No other numbers will multiply together to give me negative 15. So from this list, I have to find the pair of numbers here that will add together to get positive 2. So that's going to give me my last pair here, this negative 3 and the 5. So we can see, right, I already have a negative and I have a positive. So the 5 is going to go with my addition, and the negative is going to go with my subtraction. Okay, and that's how we factor. We just took our trinomial and we just broke it down into two binomials, into something a little bit simpler. Okay, and it's still equal to 0 here. From here, right, a lot of the times it'll say find the roots of this trinomial. So you'd have to factor, and then from here you'd have to solve. So you'd say y plus 5 equals 0, or y minus 3 equals 0. So you'd have two solutions again, right? So you subtract your 5, you add the 3. So your two solutions are going to end up being negative 5 and positive 3. Those are your two roots, okay? We could also, since we said factoring is like doing the opposite of the FOIL method, if we went back and we FOILed our answer, we should end up with the same exact thing. So I'll show you after we do our X method for this as well. Okay, in the X method, our first step is to set up a big X. In the top of the X, we're going to put our C value, and we're going to take that negative with it. So we're going to put negative 15 in the top of my X here. In the bottom of my X, I'm going to put my B value, which is 2. Okay, and again, I'm going to list out all my factors of negative 15. I'm going to find all those numbers that will multiply to get negative 15. So we'd say 1 and negative 15 again, negative 1, positive 15, 3 and negative 5, and negative 3 and positive 5. And just like before, the only pair that's going to add to give me positive 2 is going to be this negative 3 and 5. So this negative 3 and 5, once I find that pair, that's going to go on the left and the right of my X, and it doesn't matter which one it goes on. Once I have that, then I can set up my binomial. So we're going to say y, and then our sign is going to be whatever the sign is on our numbers here. So we would say y minus 3 and y plus 5. And again, you would follow the same exact process to find your roots. So you would subtract the 5 and add the 3 once you set them equal to 0. But we want to show you, right? We want to show you that if we FOIL this, we're going to get the same exact thing. That's how we can check our answers, right? So y, we do our first times our first. So y times y gives us y squared. Our outer terms, the y times 5 gives me plus 5y. Our inner terms are negative 3y. And our last terms are negative 15, right? So if I simplify this all together, we're going to get y squared plus 2y minus 15, which means we did something right? We have the same exact trinomial again. So we can try a next one too. So I want to start with the X method on this one. So again, set up our big X. On the top is going to be positive 3. And on the bottom is going to be negative 4. So we're looking for two numbers that multiply to get positive 3, but add to get negative 4. So if we list out all of our factors of 3, I would have positive 1 and positive 3, right? Or I could do negatives. I could multiply negative 1 times negative 3 and get positive 3 as well. And this is going to end up giving us our answer, right? It's going to give us our correct pair because negative 1 and negative 3 will add together to get negative 4. So these are going to be our left and our right side of the X. And again, we can set up our binomials. Say x minus 1 times x minus 3. Again, if we solve for the roots, we would say x minus 1 equals 0, x minus 3 equals 0, right? And you're just adding both of these, so you'd get x is equal to 1 or x is equal to 3. Okay, so that was our X method. If we did the parentheses method, right, first things first, I'm going to put my binomials, right, start setting them up. Then I'm going to figure out what types of signs I need, right? So if I have a negative b and a positive c, that means I'm going to end up using subtraction on both of these binomials, and I'm getting that from our original rules here that we started the video with. So we know that both of these have to be negatives. If again I went through and I listed all of my factors, we would know we'd have -1, -3. So we'd put those in, right? And then we're pretty much done, right? We could find the roots, but that's a quick and easy process. So the X method tends to maybe take up a little bit more space. Parentheses method is a lot of doing it in your head. Personally, I think the X method is a little bit easier just for myself. It may not be easier for you. I like the X method a little bit better because I can see everything in front of me. It just makes sense in my head. So those are two types of examples. I want to show you two other types. So the difference between what we just did, right, is both of these trinomials are equal to 0, right? On my next two examples, they're not equal to 0, okay? So before I factor, I have to make sure that my trinomial is set equal to 0. I cannot factor if it's not set equal to 0. So on this first example here, I'm set equal to -4. So in order to set it equal to 0, I'm just getting all of my terms on the same side. I'm just going to move whatever's over here to the other side. So we would add the 4, right? So what we're actually factoring is going to be t squared minus 8t, and that plus 4 is going to go with the 8. So plus 12 equals 0, okay? That's what I can factor, and the same thing for the X method as well. So both of these methods, you have to make sure that your trinomials are set equal to 0 before you do any type of factoring here, okay? So if we start with the parentheses method here, so I have two binomials with a t, right? And I have a -b and a positive c. So again, they're both going to contain subtraction in them. So now I want to list out all of my factors of 12. And I want to list them out if I know they're just double negatives, right? So I could do -1 and -12. I could do -2 and -6. I could do -3 and -4, and any version of the positives here as well. So from this list of factors here, I'm trying to find the pair that will add up to be -8. So it's going to be this middle pair here. So we would say t minus 2 times t minus 6 equals 0. And that's how we factor, right? That's the whole factoring method. If I told you to find the roots, you would set these both equal to 0. So you would end up with t equals 2 or 6, +2 or +6. Using the X method, again, 12 goes on the top, -8 goes on the bottom. So you always take the sign. And if I listed all my factors, right, this time I would literally list every single type of factor, not just the negatives. So I'd list 1 and 12, -1, -12, 2 and 6, -2, -6, 3, 4, and -3, -4. Again, if I didn't do this whole process first, we would find that -2, -6 are going to be our left and our right side here. So again, we set it up the same way, x minus 2, x minus 6, and you can find the roots again. And you could do, just like I did here, obviously our variables here are t's everywhere else. I accidentally messed up and I put an x. If that happens, it's not a big deal. I'm more so looking that you understand how to get these numbers in these two binomials first. So similar to the number 3 here, we have this last example. So I want to move this 6m. I want to get it on the other side of the equal sign with everything else before I even think about factoring. So we're going to subtract the 6m, subtract the 6m. So we'll get m squared plus m minus 20 equals 0, and that's what I can start to factor. And again, I'm going to switch. I'm going to do the X method here now. So top number is my C value, right? Bottom number, this M doesn't have a coefficient with it, right? But it's actually invisible, right? We have that invisible coefficient of 1. So that's what we're putting on the bottom here. Even if this said minus m, then we'd put a -1, okay? So even though a coefficient may not be written there, you're always going to put your placeholder of 1 there, or -1 if it was a minus sign. So we're going to list our factors of -20. We could have -1 and +20. We could have 1 and -20. We could have 2 and -10, or -2 and +10. We could have 4 and -5, and we could have -5 and -4 and +5. Okay, and from our whole list, we're looking for the pair here that are going to add up to +1, right? So that's going to be this last pair here. It's going to be the 5 and the -4, okay? This one would have given me -1 if I chose the second to last. We're looking for a positive, so it's going to be -4 and 5 here, okay? And then we have our parentheses, so we're going to write x minus 4 and then x plus 5. Again, we can find the roots. We set them equal to 0, so x minus 4 equals 0, x plus 5 equals 0. Add the 4, you get x equals 4. Subtract the 5, you'd get x equals -5. So if we did the parentheses method, same thing. I'm going to have my m's, and I made that same mistake again. I didn't use my m's, I used x here again, so it's not a big deal. So we have our two binomials, we have our m's. So this time, our b is positive, our c is negative. So one of these has to use addition, one of these has to use subtraction. Given that they're both opposite, we're going to have to write out all of the factors like we did over here because they're different signs. And we'll still, again, I'm not going to write the whole list again, but we'll still find that it's going to be -4 and 5. So the -4 goes with the subtraction and the 5 goes with the addition, and we would solve, again, the same exact way just to find your roots as well. So I hope this video helped. Like I said, it is totally up to you to use whichever method you feel most comfortable with. You are not responsible to know both of these, just whatever you think is easier for you to use. If you have any questions, email me at any time. And I think we're good.